Ever pondered how statisticians make sense of vast data and draw precise conclusions? Welcome to the realm of statistics, a fascinating universe where numbers speak louder than words. It's the artful science that helps us navigate through seas of complex data, reach meaningful insights, and make informed decisions. At the heart of this universe lies a powerful tool, hypothesis testing. It's the statistical superhero that battles uncertainty and brings clarity. Hypothesis testing, a statistical superhero, but how does it work? Imagine you're an alien researcher trying to determine if humans on average have more than 2 eyes. A peculiar hypothesis indeed, but a fantastic way to comprehend the steps of hypothesis testing. First up, state the hypotheses. The null hypothesis is your status quo, the hypothesis you're trying to challenge. In this case, it's that humans on average have 2 eyes. The alternative hypothesis, on the other hand, is the hypothesis you're testing for. Here it's that humans on average have more than 2 eyes. Next, formulate an analysis plan. This involves deciding on the significance level and the statistical method. The significance level, typically set at 5%, is the probability of rejecting the null hypothesis when it is true. The statistical method could be a t-test, chi-square test, or any other relevant method contingent on your data type and research question. Now it's time to analyze the sample data. Using the chosen statistical method, calculate the p-value. The p-value is the probability that you'd observe the data you have, or something more extreme, assuming that the null hypothesis is true. The lower the p-value, the stronger the evidence against the null hypothesis. Finally, interpret the results. If the p-value is less than the significance level, then we reject the null hypothesis. This suggests that our data provides strong evidence for the alternative hypothesis. However, if the p-value is greater than the significance level, we do not reject the null hypothesis. This doesn't mean the null hypothesis is true, just that we don't have strong enough evidence against it. Remember, hypothesis testing is not about proving the null hypothesis wrong or the alternative hypothesis right. It's about assessing the strength of evidence against the null hypothesis. So, do humans have more than 2 eyes? The hypothesis test will tell. So, what did we learn from our alien researchers' hypothesis test? Well, for starters, we've seen that hypothesis testing is not as far-fetched as it sounds, even when applied to an eccentric scenario like an extraterrestrial conducting a study on human eating habits. It's all about the systematic approach. Firstly, stating the correct hypotheses is vital. Our alien researcher started with a null hypothesis that all humans eat the same amount of potato chips and an alternate hypothesis that they don't. This gave a clear direction to the research. Next, the choice of the right significance level and statistical test was crucial. Our researcher used a significance level of 5%, which means there was only a 5% chance of rejecting the null hypothesis if it were true. The statistical test chosen, an ANOVA, was aptly suited for comparing the means of more than 2 groups. Finally, interpreting the results correctly is of utmost importance. When our researcher found a p-value less than the significance level, it led to the rejection of the null hypothesis, suggesting that not all humans consume the same amount of potato chips. These are the key elements that make hypothesis testing a powerful tool in statistics. Remember, with great statistical power comes great responsibility. Use hypothesis testing wisely. A powerful tool in the right hands, isn't it? It's like a compass guiding you through the vast ocean of data, enabling you to make sense of seemingly complex information. It's about extracting meaning, unveiling hidden patterns, and making informed decisions. Hypothesis testing, a crucial part of statistics, is akin to a detective's investigation. It's about challenging assumptions, examining evidence, and drawing conclusions. It's an intricate dance of numbers that allows us to test theories, validate ideas, and make predictions. Consider the power of statistics next time you're faced with a seemingly impossible question. It might be the key to unlocking the answer. But remember, the power of statistics is not just about crunching numbers. It's also about asking the right questions, framing the right hypotheses, and interpreting the results in a meaningful way. So the next time you're faced with a sea of data, remember the power of statistics and hypothesis testing. Until next time, keep crunching those numbers.